Welcome to this tutorial on curve fitting. In this tutorial, we will demonstrate curve fitting FET simulation. Here I am using Ubuntu Linux operating system version 16.04, Java version 1.8.0, Firefox web browser version 60.0.2. Learners should be familiar with topics in high school mathematics. Using these simulations, we will look at lines, quadratic polynomials, cubic polynomials, quartic polynomials, reduced chi-squared statistic and correlation coefficient R-squared. Let us begin. Use the given link to download the simulation. I have already downloaded the curve fitting simulation to my downloads folder. To open the jar file, open the terminal. At the terminal prompt, type cd downloads and press enter. Type java space hyphen jar space curve hyphen fitting underscore en dot jar. Press enter. The file opens in the browser in HTML format. This is the interface of the curve fitting simulation. Observe the help button, the functions box and the data points bucket in the first quadrant. In the functions box, linear and best fit radio buttons are default selections. Let us click the help button. A legend for draggable error bars appears in the first quadrant. The data points can be pulled out or put in the bucket. In the fourth quadrant, best fit equation is seen with the display boxes for A and B. The equation is y equals a plus bx. Below the display boxes is the correlation coefficient R squared. In the second and third quadrants is a scale for the reduced chi-squared statistic. The formula for the chi-squared statistic is given in the help box. Below the formula, we see the conditions for fit. Good or very good fit of data with the equation is seen with a chi-squared statistic of or below 1. Let us click on Hide Help to hide these boxes. Drag 3 data points out of the bucket. Place them at -10, -4, -4, 4 and 5, 10. Placing the mouse on them will show their coordinates. Note that the equation for the best fit line drawn is y equals 6.07 plus 0.912x. The correlation coefficient R squared for the best fit line is 0.9616. The closer the R squared value is to 1, the better is the prediction of variance in y from x. Note that the reduced chi-squared statistic is 6.74. The bar is red. Click on Help and note that this means that the fit is poor. Again, click on Hide Help. Let us drag another data point and place it at 0, 11 on the y-axis. Note that the best fit line becomes y equals 7.51 plus 1.004x. The slope of the best fit line has increased slightly from 0.912 to 1.004. The y-intercept has also increased from 6.07 to 7.51. The data point 0, 11 is further away from the best fit line than the other points. Note how the r-squared value decreases from 0.9616 to 0.8529. The prediction of variance in y from x with this equation has become less reliable. Note also how the reduced chi-squared statistic has increased from 6.74 to 18.66. Drag the data point from 0, 11 to 0, 6. Note how the equation becomes y equals 6.05 plus 0.911x. The r-squared value increases to 0.9635. The reduced chi-squared statistic falls to 3.37. Drag the data point from minus 4, 4 to minus 4, 3.5. The r-squared value increases to 0.9772. The reduced chi-squared statistic falls to 2.12. The bar now becomes green. Click on Help. The green zone shows good fit. Click on Hide Help. A true best fit line explains all the data and gives a good prediction of y values from x values. Click Adjustable Fit radio button. Drag the sliders A and B to values close to 0. Observe how this erases the line drawn earlier. A line parallel to the x-axis is seen. Slider A and B values will be displayed in the boxes. The data points are still where we placed them, but the reduced chi-squared statistic is very high and in the red zone. The r-squared value is 0, meaning poor correlation. Click the Best Fit radio button again. Note down the values for A and B, 5.94 and 0.918. Again, click Adjustable Fit radio button. Now drag sliders A and B from end to end. Observe the effects of these changes on the line. Drag slider A to 6 and B to 0.97. The line looks like the best fit line we saw earlier. Note r-squared and the reduced chi-squared statistic. Check Show Deviations and click Best Fit. The vertical lines from the data points to the best fit line show the deviations from the line. Drag the points at minus 4, 3.5 and 0, 6 into the bucket. Note how the line passes through 2 points. R-squared approaches 1 and the reduced chi-squared statistic becomes 0. The fit has become too good because a line is defined by 2 points. Without a third point, there is no question of the line being anything but the best fit line. Now we will look at some information for you to graph a quadratic polynomial. Quadratic polynomials are of the form y equals a plus bx plus cx squared. The degree of the polynomial is 2. Hence it is called quadratic. The function can have a maximum of 2 roots. Drag and place data points at the following coordinates: minus 9, 10, minus 7, 2, 2.5, minus 2.5 and 5, 10. Note the r squared and reduced chi-squared statistic values. Also click Adjustable Fit and see effects of A, B, C on the fit. This is what the best fit graph for this quadratic polynomial will look like. Cubic polynomials. Now we will look at some information for you to graph a cubic polynomial. Note the r squared and reduced chi-squared statistic values. This is what the best fit graph for this cubic polynomial will look like. Quartic polynomials. Now we will look at some information for you to graph a quartic polynomial. Note the r squared and reduced chi-squared statistic values. This is what the best fit graph for this quartic polynomial will look like. As an assignment, change the data points and their number. Follow the steps shown earlier to get best fit graphs for all polynomials. In this tutorial, we have demonstrated the curve fitting FET simulation. Using this simulation, we have looked at lines, quadratic polynomials, cubic polynomials, quartic polynomials, reduced chi-squared statistic and correlation coefficient r squared. The video at the following link summarizes the spoken tutorial project. Please download and watch it. The spoken tutorial project team conducts workshops using spoken tutorials and gives certificates on passing online tests. For more details, please write to us. Please post your timed queries in this forum. This project is partially funded by Pandit Madan Mohan Malaviya National Mission on Teachers and Teaching. Spoken Tutorial Project is funded by NMEICT, MHRD, Government of India. More information on this mission is available at this link. This is Vidya Iyer from IIT Bombay signing off. Thank you for joining.